Hi, I'm Joseph Farrow. This is Critic number 3, topic A, evaluating a definite integral using substitution. So our integral is from 0 to 4 of x cubed times the square root of x squared plus 9 dx. The first thing we're going to have to do is find a suitable u value to substitute in for this. Usually this is going to be an inner function. In this case it's easy to find. It's going to be that x squared plus 9 since that's inside the square root. And then going off of that, the du value is going to be 2x times dx. And plugging those in for our integral, we see a problem because it won't cancel out all the x's. So to solve that issue, we break up the x cubed into an x squared and an x, and then solve for x squared and x dx instead of just u and du. And after you substitute those values in, you'll get the integral of u minus 9 times u to the 1/2, which is the simplified of the square root of u, times 1/2 du. You also notice that the limits have changed, and that's because when you change the variable, you have to change the limits, which is simple. So since we solved this value of u here, we can plug in our old x values for that. So when x equals 4, u is going to equal 25, and when x equals 0, u is going to equal 9. So with all those, we basically just have a regular integral to evaluate. And the first step there is to take the antiderivative, which of this is going to be 2/5 times 1/2 u to the 5/2 minus 2/3 times 9/2 u to the 3/2. And you're going to evaluate that from 9 to 25. So simply plug in 25 into the new antiderivative and subtract 9 from that. Subtract the values once you plug 9 in. Once you evaluate all those numbers out, it's going to be 625 minus 375 minus 243 over 5 minus 81. Once you find all common denominators, get those all to be over 5, and evaluate, it's going to end up being 1412 over 5, or 284.4.